Let's keep going with Math 098, section 3.3, and we're working with compound inequalities, and we're going to still use interval notation. That's what I want you to get used to. The other thing that you need to learn is some of these symbols. For instance, this is what is called the intersection symbol. It's basically a fancy AND statement that we use in mathematics a lot. So what we're looking for A intersection B is all numbers that are in both sets. That's what AND means, both. So if we want an odd number greater than 0 and less than 10, we're talking about 1, 3, 5, 7, 9. Well, only 1 and 3 are in both sets. 5 is in set A, 7 and 9 are as well, but they're not in set B. And same with 2 and 4, they're in B, but they're not in A. So A intersection B is equal to the set of numbers that include 1 and 3, and that is it. So you'll see some problems like that. As we look at the next one, it's another intersection, so they need to be true for both inequalities. Well, if you solve the first one by subtracting 3 over, we're looking for values that are smaller than 5, and, well, this is a two-step process. For instance, you add 1 first and divide by 2. We're talking about x is less than 2. So if we look at and we graph that, so we want numbers that are less than 5 and numbers that are less than 2. Well, if we graph both of them, where do the two lines overlap or intersect? That's why it's called an intersection. Is you can just look at, I'm just going to highlight, they overlap on this region, so the interval notation would be from negative infinity until we get to 2, and once we get to 2, it only works for one inequality. It no longer works for both inequalities. So you might want to pay attention, because some students get in the habit of, after they find this and then they memorize that and are all the numbers in between. That's not always the case, so don't just automatically assume that. So as I look at the next one, I would divide the 4 over. Well, 0 divided by 4 is still 0. Subtract 2, so subtract 2 from 8 and you get 6, and when you divide by 3, 6 divided by 3 is 2. So if you were to graph this, again, this is an AND statement. If you want values that are smaller than or equal to 0 and numbers that are bigger than 2, where do they overlap? Where's their intersection? And that answer is nowhere. None. No solution. Again, feel free to pause this video and try this on your own and think about what needs to happen in order to get that to be a solution. I always have students that struggle with this as well, and that I get it, but all it's saying is, because math people are lazy, is we could write it in this way, and these are implied AND statements. 5 minus x is less than 9. Now for me, I prefer getting my variables on the left side, so I'd add x to the left side. It's less than 5. And then subtract 3 to the right side. 5 minus 3 is 2. And, well, if you subtract 5 to the right side, you have negative x is less than, adding 5 over here, or sorry, subtracting 5 over there would make it 4. 9 minus 5 is 4. But then when you divide by negative 1, you have to flip that inequality, negative 4. So when you graph this, now you can actually see the points of intersection. I think you can. So we want values smaller than 2, but then you also want values that are bigger than negative 4. Well, where do they intersect? Where do they overlap? Is that region, I'm trying to get a highlighter, there we go, this region between the two of them. So what's our final answer? Is in interval notation, negative 4 to 2. Now, I get why students confuse this because they think it's the ordered pair. I'm talking about values for x that are bigger than -4 and smaller than 2, but not including them. Now, as you get better at this, I've actually taught students, and they seem to understand it, as really you just have 3 parts to an equation. It's like equals equals. Well, if I asked you to solve just one of those, I think all of you would say, well, you add 1 to the other side. Well, now you just have 3 parts to add 1 to. So we're looking at -3 is less than or equal to x over 2, which is less than or equal to 4. So now, I'm changing colors, to get rid of dividing by 2, you multiply by 2. Well, you have to multiply all 3 parts by 2, and we're multiplying by a positive, so it's not going to change the value or change the inequality at all. And you could have done this on exercise 4, by the way, as well. I just decided to split it up to explain it that way. 2 times -3 is -6. 4 times 2 is 8. And when we have it written like this is another AND statement. So we want values for x that are, I'm going to count by 2's. 4, 6, 8. Smaller than 8 from this statement. But we also want values for x that are bigger than -6. So again, I'm going to count by 2, 2, 4, 6. And where those 2 regions overlap is in between. And now you use brackets because we are equal to. So as I mentioned, you can always use Desmos to check graphically. Go ahead and pause this because I'm going to jump to a graphing calculator to show you. I'm going to jump to Desmos. So if you're using Desmos, notice that if you were to try to do the next one, you get a emergency sign and a symbol in here because it can't do both at the same time. But it can solve one at a time, and you can see you get the left bound of -6. So what I'm going to do is just copy that equation, put it down here is less than or equal to it was 3. And now, and let me hide the red one. You can see that it goes up to x equals 8. And if you put them together, you can see it goes from -6 to 8. And graphically, it's a lot busier than what you need to know. Plus, you need to know how to do brackets to get the correct answer. Well, the nice thing about Desmos actually is if you don't have an equal to, it puts a dash line, which we know is an open circle, which we'll get to later in the unit. Whoops, I wanted that to say equals, because I want you to have the correct answer. So from -6 to 8, and we're good. So going back to our notes, here's another one where we're doing the union. So union means or. I think you've seen this before, and we use this a lot. So it needs to be, if we're doing A union B, it's one or the other. And this is pretty much the same. It's an odd number greater than 0, less than 10. So you want to include all those odds, and it could be in both sets. If you notice, 3 is in both sets. But you want to include 2 because it just has to be true for one of them. It doesn't have to be true for all of them. 4 is only in this one. 5 is shared between both sets. 6 is only in this set. 7 is only in set A. We skip 8 because that's not odd, and it's not in set B, but we want to include 9. So it must be true for 1. So only necessary for 1. Whereas the intersection, I don't know how to spell unnecessary, for one set. For the intersection, it had to be true for both. So as we do this with an OR statement, I'll start by subtracting 5 over. 8x is less than or equal to 3, so x is less than or equal to 3/8. Or add 1 over, x is greater than or equal to 3. Well, if you're looking at that on a number line, 0, 1, 2, 3. So we want values that are bigger than 3, and then 3/8. Okay, well, We don't care where they intersect because they don't intersect anywhere, but your answer in interval notation would be negative infinity to 3/8 with a bracket, and then we use that union symbol again from 3 to infinity because they all satisfy at least one part of your problem. And then here's your last problem, solve and write in interval notation. Again, only has to be true for one when you have this OR statement. So add 2 over. So negative 3x is greater than adding 2 to negative 8 is negative 6. Don't forget when you divide by a negative, you switch that inequality. Negative 6 divided by negative 3 is positive 2. And this one, if x you divide by 5, you get x is greater than 0. So on a number line, what you'll see, you have 0, want to include any number that way, but then 2, any number this way. Well, over here, it's true for 1. Over here, it's true for both. Well, in between, to the right, it's true for 1, so it works. In between, it works for both. So this is an example because everywhere on the number line, it works for at least one of the equations. Some places it works for both, that you want all real answers. It doesn't matter what x is, it'll work. X will satisfy one of these two equations. Some of the values, it actually satisfies all equations. Inequalities, I should say. So that's it for these notes. Here's your assignment, and you should be good to go.